Welcome to Tough Tech Today with Mayan and Miller. This is the premier show featuring trailblazers who are building technologies today to solve tomorrow's toughest challenges.
So welcome to Tough Tech Today. We are really excited to be joined today by Jeff Smith. Now, all of you, remember, we are kicking off our newest season, and our first theme is about blue technologies. And so we're going to ask Jeff imminently to walk us through the lay of the land, so to say, or the lay of the sea, I should say. But first, Jeff is a guru of undersea systems, autonomous systems, and that Venn diagram of where those intersect. He's currently the vice president and general manager for autonomous and undersea systems at Saab. He has quite the credentials in terms of amazing startups that he's developed and companies he's contributed to, including Bluefin, Riptide, support for the U.S. Navy over decades. And so, welcome, Jeff. Please help us bring us into your blue world.
Forrest, JMO, it's a pleasure to be here. I really appreciate the opportunity. It's, the ocean's, it's an amazing part of the planet, right? Over 70% of the Earth's surface. I go back to, as a child, I can remember every time Jacques Cousteau was on in the early 70s, we were all over it as a family watching it, and just really, grew up sort of out in the woods, but always had a love for the ocean. I'm an avid scuba diver. And my career, fortunately, has kind of come along the path that I've been able to work in a lot of technologies supporting the ocean. And I found this sort of magic niche between the undersea and robotics. And it's just, as the saying goes, if you have a passion for what you do, you'll never really work a day in your life. And I kind of feel like that's where I am. I found a technology area that I can really thrive in, and in an area that I'm passionate about. And there's a lot of work there, given how much we know about the ocean. Given what's needed, given a large Navy customer with a lot of critical mission needs, so it's sort of all aligned into the space I'm in, and into the career I've sort of laid out.
That's amazing. So you mentioned that Jacques Cousteau was kind of an inspiration for you. Was there a time in your career where you realized that this was blue tech was an area where you could actually spend your career?
So the term blue tech really hasn't been around that long, right? So, I guess from, coming out of school and going into General Dynamics and working on submarine systems, a lot of that work I did sort of first half of my career. So it was a lot around manned systems. I started to get some into the remotely operated vehicles and supporting systems for that. And I was kind of finishing up a master's degree from RPI in robotics, and I kind of saw that the unmanned systems were really starting to come online. Like the aerial systems were always there, leading the market for unmanned, but the undersea started to gain some traction there. Early 2000s, a couple smaller companies, an MIT spin out, a Woods Hole spin out, really starting to do some exciting work. And fortunately, GD at the time tasked me to go figure out how to get involved in that space. And that really led me to start plugging into those companies and figuring out, seeing an opportunity where it really, allowed me to get into something that I just had a natural affinity towards. So from a blue tech perspective, probably a little more than half my career, I'd say, close to 20 years, which, I guess I've been doing this a while. 30 years over 30 years this year supporting the Navy across the board with a bunch of programs. But truly the undersea robotics side in that for about 20 of that.
Is some of your contributions in terms of creating companies as well as working within very large established companies? It sounds like you've been able to navigate your career as an engineer. And also as sort of the business and managerial aspects sometimes that it could be perceived that those are like very different silos, yet you imbue sort of all of those traits.
And I think it goes back to I consider myself extremely lucky in everything I've been able to do in this space. And, I go back to General Dynamics and sort of, you start there as an engineer. You eventually become sort of, if you're on the career path of, an engineering manager, then program management becomes a pretty good thing. So you jump into the program management side and, more business capture. And, GD really, I can't say enough about the 15 years I spent with that company. I worked a lot of different areas, and it really, it got me on the track to more, executive level positions. When I jumped into Bluefin, I stood up a program management group for Bluefin, but then I really started working on Navy capture and laying out solutions for what we were going after under Bluefin. Became the chief operating officer there. But then I started, I jumped out of that to start Riptide. And, at that point, I hadn't really done any engineering work for, probably at least 5 or 8 years. And, when you start a company in your kitchen, in a small company, there were only three of us to start, you really have to do everything. And I really, it was really fun for me to get back into that engineering work and start working designs and building stuff and getting a lot more hands-on than I had been in, quite some time. And it was really rewarding, but it really, it helped me, I think, at a time get a lot more back into that really technical solution focused and getting my hands dirty. And, that obviously sort of moved to, evolved to where I am today. And, we started this group in Saab, again, small team, 3 people. It was really like a startup. And, obviously pulled in a fairly significant staff now, and we're growing pretty quickly again. But I enjoy the hands-on work, right? I enjoy being on a boat. I enjoy trying to program vehicles to do things. It's, there's definitely better engineers than me, I will say. And fortunately, a lot of them work for me.
That's always great. You got to be surrounded by a good team. So when you started Riptide, like what was your key objective, and how did that evolve over the 4 years?
I guess I love Bluefin, right? It was just a really special company for where we were at the time in the 7 years I was there. Really close knit group of people, and the UUV community, I guess, and there's a lot of companies in this space, a lot of competition, but they've all kind of started very similarly, right? Smaller companies working to sort of develop agile solutions and more the S&T side. And the reward for a lot of those companies was always, you need to win a big Navy program of record. And obviously big, large primes know how to do that, but the smaller companies sort of struggle with it. And, I was somewhat fortunate in that I came from General Dynamics, right? I had that big company capture experience, and that led us to a couple things at Bluefin, frankly, partnering with General Dynamics, where we were able to win sort of those big programs and get a good foundation. But you look at that period from 2015 to 2020, there was a lot of consolidation in the market and a lot of these big defense primes buying the small sort of agile companies.
But often when you set out to do a startup, you have a particular vision. And then when you get 4 years down the road, it kind of shifts. So I was kind of curious on what was your initial kind of problem set and where did you end up?
So I guess, the thing with Riptide is what I saw, frankly, was an opportunity in the market where there was a gap. The average vehicles when I started Riptide were over $1 million in the UUV space. And we had started to see some demand signal from the US Navy that, they wanted larger quantities of vehicles, right? And much, much lower cost to get the quantities up. And the UUV market sort of does lag the UAV market. So, there's lots of, not lots, but large global hawks that cost millions and millions of dollars. But if you look at the market now, there's, tons of small UASs that support our military. And to an extent, when you look at the problem in the ocean, you just can't put that many systems out, especially when they cost millions or tens of millions, or right now, we have the XL UUVs with the Navy for hundreds of millions. And it's just, it becomes sort of unaffordable. But if you can get things out there that really drive the cost down to open up the volume and the quantities of systems, or you put more and more nodes out there, that was really the opportunity we saw. So in starting Riptide, there was kind of two things that drove us to how do we create a $10,000 UUV. One was we think there was a pretty good demand signal there, and the second one was I didn't have an investor when we started, and I was broke. So I had a 10K credit card limit, and I figured if I could buy everything I needed to on that, I could build a vehicle that I could sell for that, and hopefully make some money.
Awesome. So the credit card limit was part of the design trade space.
It got us started. Yeah, but I mean, seriously though, it did drive us to make a lot of decisions, I think, for, how do you do something at a real design to cost when that hadn't been a large factor in the space. So it forced our materials and how we built things, and it drove us to a lot of additive manufacturing because we could do that without having to invest in the molds. There's a lot of things that really sort of taught us to do, and it taught us a good amount of efficiency early on. I come back to coming over to Saab and sort of starting from scratch. The first program we went after was this Mark 39 EMAT, Expendable Mobile ASW Training Target. And it's historically it looks like a UUV, but it doesn't sort of meet the typical criteria of a UUV. It's really it's an ASW training target, but it's expendable. And the Navy's been buying it for 30 years almost, and it's less than 10K. So but we're building them in quantities of 1,200 units a year. So it really, I kind of see like what we've gotten to with standing up this group at Saab is sort of the culmination of the vision we kind of had early on back in 2015, and just trying to get into the low-cost UUV market.
Could you walk us through some of the problem sets that were motivating for Bluefin, as well as spanning your career, how those may have changed? Like what walk us through, help us sort of visualize some of the specific kinds of tasks, at least to the level of detail that you can share. That's like, say, not classified Navy stuff, and how that works. So probably the biggest challenge in Undersea, and it's the one that really affects every single vehicle that's out there. It's energy. At the end of the day, the propulsion power, has to overcome drag, and the water is 800 times more dense than air, and drag is directly proportional to the density of the medium that you're traveling through, right? So, in air, you really don't have much of a drag problem. In water, you absolutely do, right? There's a reason that every U.S. Navy submarine is powered by a nuclear reactor. You're probably never going to put a nuclear reactor on a small little vehicle, and certainly not an expendable one. But that energy problem is it's a big deal. And how do you get and fortunately, you kind of look at the last 10, 20 years, there's been steady improvements in energy densities and battery technology. The electric car vehicles really driven a lot of that, and it certainly will drive it and continue to drive that. But that's a problem that sort of goes across the board. I've been involved with some new energy development programs over the years. Early on when I started Riptide, I actually linked up very closely with a company called Open Water Power. It was an MIT spin-out that had an aluminum seawater battery that was really tremendous potential for what that could have done. It was acquired a couple years after I got involved with them by one of the large defense primes again, and I think there was a lot of potential for the technology, but I don't think it still ever sort of crossed the finish line to what it really could have done. But certainly batteries are a known and understood technology, and they continue to evolve. And every once in a while there's something, new anode capability, new electrolyte, something that gives it a little bit bigger kick. And we're always sort of leaning into what's next. And there's some things with solid state batteries that are coming along that are of interest.
A lot of the graphene stuff we monitor pretty closely, but it's an important area for the technology and where things go. The other big challenge undersea is obviously the environment. It's corrosive, it's high pressure. There's a lot of push in recent years for deeper and deeper things. As some things open up with the ocean from an exploration side, clearly, because the bulk of the ocean is very deep, right? You have reasonably shallow, easily accessible places along the coast and the continental shelf, but a lot of the oceans is rather deep, and the Navy has a greater need to go there. We're putting, oil explorations driving deeper and deeper as the near shore sites start to tap out. But there's a lot of things there with, as you get into vehicle designs, at the end of the day, a UUV is what makes a UUV is really sort of, it goes slow, right? It's efficient, it's neutrally buoyant. So it has to displace its weight in water. So that kind of drives you to, how much you can put in it to offset that water's not too dense at the end of the day compared to some of your metals, obviously. So, you really have to get high strength to weight materials. We've done a lot in pushing deep with, for instance, carbon fiber. That clearly was a recent, big thing in the news with the Titan submersible on the Titanic. Tragic event that never should have happened. There's certainly limitations to those materials, and unfortunately, people learn that with their lives.
So what is the, it seems like it takes a whole plethora of technologies to increase the capabilities of your UVs. Would you say like a breakthrough in battery technology is probably kind of the biggest thing that would cause a step change in the capabilities of these vehicles, or is it something else that I haven't thought about yet?
I mean, the battery technology certainly is an area where if for instance, I obviously do a lot with the Navy. If the Navy can put systems out there instead of for hours to days, days to weeks, weeks to months, that really drives a whole new mission areas, right? It frees up manned assets to go focus on things that are better for them and leave sort of those longer persistent things that unmanned systems really are ideal for. But it really comes down to, how do you get something to stay in the environment for a long time that is taking power? There's been some systems over the years that do wave action, power reclamation. We've worked a couple systems, for instance, solar, some wave generating, power regeneration. And there's also talk about, basically putting down undersea gas stations where, vehicles can plug in, power back up and continue on the way. But, at the end of the day, it kind of becomes what's practical for the cost. I've been in the last several years really working a lot of the expendable system side. So, how do you get the cost down to be able to put the systems out, and use them for as long as they work, right? And that's an opportunity in this space. But clearly, bigger systems too. And the Navy's making a big push for larger vehicles. And, the beauty there is you typically run the same sensors as even the smaller vehicles do. It's just you're building a system that much bigger for really the battery volume that it gives you. And then you're driving a propulsion system that's driving a much bigger vehicle that's really just a big battery. So you're kind of fighting yourself when you start looking at how that all works out.
So with the focus on autonomy that you and your team have had, and is that something that is built that plays into or helps inform, say, like the Department of Defense has their replicator program and the concept of like mass and swarming and sort of several flavors of that, which I think the aerial systems tend to be what folks often think about because we can go and buy a quadcopter drone for relatively low cost nowadays. But is that a big sort of impetus, or perhaps the other way around, that the discoveries that you and your teams have made over decades now helped to say drive the DoD to say we need to get better at coordinating and deploying these kinds of attributable systems?
Our new CTO in Saab is Dr. Julia Allen, and she would probably slap me for not saying when you talk about the challenges the whole AI ML problem. When you look at the the environment with Undersea, your air's got a lot of benefits, and even space, right? You pretty much have full-time communications, whereas underwater, you really don't. You're talking, if you can get an acoustic modem within range of it, you're talking 1970s baud rate kind of communications. You're not talking real time. You're not talking streaming video. The communications path is a significant challenge. So as a result of that, a lot of the undersea systems have to be smarter, right? They have to have a lot greater autonomy. They have to be able to do a lot more on their own. And, that is a whole challenge in and of itself. For the record, mechanical engineer by background. I've worked with some brilliant people on the software and autonomy side, and there's a reason that I've hired a lot of brilliant people in those areas. It's because it's the farthest thing from my expertise that there is. But, we've been making a big push within Saab. We're rolling out a new team that you'll hear more about sort of in the future here. But a lot of the, our AI ML, it's, our plan is really to make every system smarter. And, you talk about, batteries can give you a significant step change, obviously, and in the endurance of systems. But at the end of the day, the physics sort of limits what a sensor can do. But when you start talking, how do you apply AI ML to some of these problems and get the most out of that sensor? That's where there's a lot of capability that really hasn't been tapped yet.
With all this talk of robotics and advanced technologies, I want to come up for air to plug our first sponsor, the End Effector. It's an exciting new endeavor from yours truly. The End Effector is going to be your source for informed perspectives on the business of breakthroughs in advanced technologies, emerging science, and inventive design. We're kind of like a forward deployed chief tech advisor for our community of investors, entrepreneurs, and industry players. Join the End Effector mailing list so you can decode deep tech with me. Now, let's dive back under the sea with Jeff Smith. I remember reading, it was recent, I think within the past week or so, an article, I'll have to dig it up, from the journal Cell, if I recall correctly, that was sort of like biologic-inspired passive sensing underwater. And is there a greater push to make things more passive? I mean, and always like just basically more silent underwater. One, to help the whales' ears or whatever, but also on like a adversarial perspective to be roughly acoustically invisible to someone else.
Yeah, I mean the noise. There's a bunch of different ways to look at noise subsea, right? The from a sensor perspective, passive sensors are way less power hungry than active acoustics, right? You're not emitting, so you're just really listening. So from that respect, you can put sensors out and systems out that don't have the high power demands as active sensors. From a vehicle side of things, if you have a noisy motor on a system, that's probably going to interfere with the sonar, especially if it's a lower frequency sonar. So you're trying to work in spectrums that you don't want to be, and in some cases your navigation sensors can be putting out signals for, your bottom, your Doppler velocity logs, where, you don't want to walk over your imaging sensors that are also emitting basically, sonar, acoustic imaging signals. So there's signal management that happens obviously on the vehicles. And then you get into the whole, the marine mammal challenges, right? There's a lot of noise in the ocean. Ships drive a lot of that. It's not necessarily just the sonars. I was scuba diving off of St. Thomas a month or so ago, and I now appreciate why whales beach themselves. If I could have swum fast enough to the shore, I would have gotten out of the water. I had a freighter go over me, and it really rattled everything in my body. And a lot of us that were on that dive, it was painful. I just, and I clearly don't hear as well as whales do underwater. But yeah, there's significant noise challenges. There's obviously a lot of construction happening with offshore wind, oil and gas, those things, and there's a big effort to try to quiet those as much as possible, so you're not interfering with the marine mammals. And clearly, sonars are concerning depending on the frequencies and how much power is in the water. But it's a challenge.
So, how walk us through how you've learned to approach developing these kind of like these novel systems, especially since I think they're undersea, especially like deep water systems they seem like they'd be difficult to test. How do you design, build, test, evaluate, refine? What's that learning cycle look like? Because you had mentioned some like sort of agile practices that over the years and others. What kind of test beds do we need if someone's interested in getting into the space? Is there, like hypersonics testing? If good luck finding a wind tunnel that you can book time on. Is it like that?
Yeah, I don't want to say it's the dirty secret, but it is. It's actually one of the things I love about this market and doing what I do is, I have tested vehicles in, some pretty nice dive areas of the world, off of Hawaii, off of Roatan and Honduras. And, obviously operational sites, when you get to take a vehicle to, a pretty nice destination and do a job, it's a lot of fun. But I mean, ultimately the vehicles have to go in the water, right? It's what they're made for. It's how you validate them in an operational environment. I looked the last couple of years, there's a lot more activity going on the whole digital twin approach and the model-based systems engineering work that goes into sort of trying to validate a lot of those requirements early. We do bench testing and things like that sort of drive down the cost, but ultimately it's expensive to put vehicles out in the water. And the bigger the vehicle gets, the more cost that goes to, right? You're talking, you could need a $15,000 a day ship or a $25,000 a day ship if it's a large vehicle. Fortunately, one of the things that helped me with when I started Riptide was, I have pictures of me out in the lake on a paddleboard. It's pretty easy to test a vehicle that weighs 25 pounds that you can put on a commercial aircraft in your overhead and travel wherever you want to throw it out in the ocean, and it runs on alkaline batteries and things like that. But that really, at the time there was time I was starting Riptide, there was a couple other startups and spinoffs that came out of Bluefin, and a couple of my friends went and started a large diameter vehicle company. And I looked at me, and I could easily do it on my credit card, and I looked at them, and I'm like, you're going to need at least 10 mil to get to build the first vehicle. And it's there's a lot there. The cost for the systems, it depends what you're doing, but the bigger the system is, definitely the higher price it is to test and evaluate it. And then you start talking deep. The challenge with deep is, most of the development companies in the space are in New England. And sadly, there's not really that much deep water when you look at the continental shelf and where we are. You can get to a couple hundred meters, not too far off of Provincetown. But, if you're going to go to 4,000 plus meters, you're renting a bigger boat that has to go for at least 24 hours off of Jamestown to get out to the block trenches and off of several hundred miles out to shore. And if you're going to be there for multiple days testing, that drives a bigger boat, overnight capabilities, kitchens, all that kind of stuff. So it is a cost.
For those deep submersible systems, are they? I imagine almost they're all a lot bigger, or is there a class of them that are, smaller vehicles that can withstand?
It depends, right? When you look at ROVs, traditional tethered vehicles, there's a lot of small ROVs now, but they can't go that deep. The challenge with ROVs is the tether, that provides the power and the control to the vehicle. The deeper you go, that tether is, there's more drag on the tether than there is on the vehicle. So as a result, the vehicle has to now be way overpowered to be able to counter the weight of the tether. So for deep ROV systems, you're talking massive, massive vehicles, 10,000, 20,000 pounds just to be able to manage that tether. When you look at UUVs, it's how much endurance does it take to get to that depth? And from back in my days at Bluefin, typical deep Bluefin vehicle was 6,000 meters, right? 20,000 feet. And that vehicle, you could do that in a 21-inch vehicle, 20 feet long, 3,000-ish pounds. But one of the things that sort of came along as I was working with Riptide and starting to develop the lower cost systems was, how deep can you really make it go? And there was a lot of good engineering work that we did at that time. And we basically built a vehicle, a little bigger than 25 pounds, but not over 30, that could do full ocean depth, 6,000 meters. So titanium, a lot of carbon fiber in that vehicle. We learned a lot in how you work deep carbon fiber. Consequently, when the Titanic happened, we had imploded a lot of the same materials and learning what we did there. But it's, you can get a small vehicle to work at depth. The question then becomes, well, how much endurance does it have? And what can it really carry for a sensor to do a useful mission when it gets there? So there's the trade space really becomes, it comes down to size, weight, power, and what's the volume of the sensor or the effector that you're trying to put with the vehicle at that depth.
How long does it take to descend 6,000 meters?
Depends, right? If you can, there's, you go back, there was one of our competitors' vehicles, and I won't call them out by name. They had they were powered by a aluminum hydroxide fuel cell, and the fuel cell could only operate within a 15-degree tilt with the way that the electrolyte kind of flowed. So if you're swimming down 6,000 meters at 15 degrees at 4 knots, you can do the math, but it's a pretty long elevator ride, 4 to 6 hours. If you can swim vertical, you can do 4 or 5 knots typically with a small UUV. So, you can get there in, an hour or so, but it's not a free ride. With some systems, you have the ability to put, basically drop weights on, right? So descent weights. So you put a big weight on it. That's, it's an anchor. It's pulling you down. And once you get reasonably close to the bottom, you cut it, and now you got the descent for free. But, back to the point of, neutrally buoyant with these vehicles, you're not typically heavy. So you're not getting the assistance of that negative buoyancy to get to that depth without something like a descent weight.
Is there, have you seen greater encouragement of pursuing, say, like Arctic and sort of polar work with the vehicles that you're developing?
There's been a lot of work in that area. I did a couple projects there around, mostly at my time at Bluefin. Actually, right out of the gate with Riptide, one of our first orders was a Coast Guard vehicle where we went up and did an Arctic deployment on the Coast Guard cutter Healy. We had some, unique pictures of the guys going off in a little craft, throwing those vehicles out in the cold weather gear, and there's obviously there's a big demand, especially the Arctic, with just staking claims to the resources that are up there between the folks that are really right around there. So Canada's, obviously got to play there, U.S., Scandinavian countries, et cetera. We got, one of the things with Saab about coming up on 2 years ago, one of the things that we got so much attention for back, shortly after I joined was the Ernest Shackleton's Endurance off of Antarctica. So that was actually found with 2 of our Sabertooth vehicles. I don't know if you recall, but it was the back of the ship, the vehicle came in and it looked like it had gone down like weeks before, right? It had been down almost 100 years, and just pristine, a couple things growing on it, but the cold water there really preserved the wreck immaculately well. And, endurance was right across the back. It was really that got a lot of attention. That was down in the Undersea back in March of 2021, 22, sorry. And they'd been looking for that wreck for years. There was multiple expeditions that went looking for it. And several vehicles actually had been lost previously on those expeditions. You're talking under ice surveys, cold water, just lots of things that sort of make it very challenging. Interesting fact that the vehicle that two vehicles went, Sabertooths went, they were 3,000 meter rated, and the wreck itself sat at like 3,005 meters. So it was, you're right at the very limits of where that vehicle could really operate. And, successful expedition. A lot of people really happy with how that came out. And, it was great advertisement for us because it had, it was really one of those just classic legendary wrecks sort of right behind the Titanic.
I imagine it must feel, as a builder, it must feel incredible, that feeling when you get word that someone's discovered something amazing using a system that you've built.
I actually,
really
so for the record, that vehicle was built by my colleagues in Sweden, and I come on months sort of after that.
You can live vicariously.
But I posted something on LinkedIn, and one of my buddies said, like you had anything to do with it. And I remember sending him a picture of me in ski gear and goggles and everything, saying it was cold. And he's like, there's a chairlift behind you.
Did you ever discover or find something super interesting with any of your other systems?
So probably a little bit of an embarrassing story, but I lost a vehicle, one of the Riptide vehicles actually early on. We were testing high speed sort of transits with it, and we had the IMU in it I think had an orientation issue. So the vehicle thought it was going horizontal and it was going vertical, and it planted itself in the mud. We called it lawn darting. But then we had to go and find it. So it was out actually in Boston Harbor. So I worked with the Quincy Police Department, and they had an ROV, not made by Saab, but we went out for a day on the Quincy boat and looking in the area, and learned a lot actually on survey and the practical operations of sort of, they use those systems for body recovery, investigations, things like that. But we were scanning an area, and we found it was like an 1850s anchor. That's probably the most interesting thing I've found to date. For the record, my retirement plan is treasure hunting, so I hope to be able to answer it differently if you were to ask me in a couple of years.
That's great. You mark the coordinates of the anchor, you're going to go back and grab
it. I got to figure out the legality of that, because it looked good on the front lawn, though.
I'm curious, what are some of the companies or organizations to watch with your vantage point and connections across industry? Are there some entities that are doing something kind of maybe a little crazy, but it's a tough problem?
There's a lot of exciting companies in the space. I think there's also been some challenges, frankly, for the industry. I think there's, as I mentioned, there's been a lot of large defense prime acquisitions in the space, and the Navy, the way the market works is, you sort of need these programs of record to create a foundation for the business. But those programs of record are kind of few and far between. One comes along every couple of years, and then for that particular solution, it won't come back around for almost a decade. So if you can't get in, you're kind of struggling to connect the dots and connect these opportunities to get a business base. And there's just, there's not as many programs of record right now, in my opinion, as there are capabilities in the industry to satisfy. And when you look at the large primes, they're not structured to sort of go after, a vehicle sale here to oil and gas or a vehicle sale here to university. They really need these multi-tens, or if not hundreds of millions of dollar programs. So I think what's unique about Saab is we sell commercial vehicles every day. Our ROVs go out to oil and gas. We have, we're selling vehicles down 100, 150K kind of price points. So we work across both the commercial and the defense side, which is, I think, very good from a stability of the business standpoint. There's a couple companies, I think, in addition to Saab, that are really sort of, figuring out how to work a commercial model and continue to do sort of some new development. I'll give some credit to some former colleagues. You look at Anduril. Anduril has been sort of an exciting company in the space. We don't compete directly with them. They're building some larger vehicles right now, but they've done a lot, obviously, on the air side, on the AIML side, and now on some larger UUVs, with some extra large vehicles going in Australia. And some good work here going on from their acquisition of a company called Dive Technologies, which is another bluefin spin out. Really interesting company. They had a huge Series A or Series B round, I think, with like 1.6 billion. So cash rich to play in some areas and figure out sort of what's next. But I'd keep an eye on them.
Have you investigated and things that they call like transmedium craft, like sort of systems that are able to transition from sea to air, for example, and what are the complexities involved in sort of going across that threshold?
It
seems like wacky physics.
Part of that 30 years I've been doing this is you pretty much tried everything once. I have worked that area a couple times with a couple different partner companies out there. The hardest part there when you start to, go back and look at it, it's that drag problem, right? You're going from, 800 times denser water to air. So it's a different motor, right? And there's a couple things there that, I've seen some pretty creative things that others are doing in that space. The way that I've kind of looked at that, the problem you have is it's really hard to optimize for two drastically different environments like that. So from my view, the sort of a potential solution there is it's not necessarily a hybrid vehicle that'll do both. It's a hybrid system where you use the benefit of, a plane and to drop a UUV. And there's some things there that, I think it's simple, by decoupling the problem, it sort of simplifies it some. But it sort of depends at the end of the day on what you're trying to do, right? If you're trying to, if you you want a system to spend 95% of its life underwater and fly for 5 seconds, that's achievable with a vehicle, right? It really comes down to what's the requirement and what's the, how do you get there? The biggest challenge in this area is, Navy's been a tremendous customer, and they have a lot of, desire for systems and to really push, the bounds of what the unmanned systems can do. But in some cases, it's without having a basis for what the solution they need is, they don't really know how the systems can help them. Clearly there's been a lot of use in for UUVs and mine warfare and things like that. And it's a pretty straightforward problem. They've been using them that way for decades. But when you start pushing sort of these more advanced concepts and how multiple systems sort of play together and swarming and things like that, they haven't seen how that system really can help them yet. So there's still a lot of sort of, it's a gray area. And and that's, one of the reasons that we fund some of the internal research and development work that we do. It's really, if we think there's a good opportunity here to demonstrate a capability, then that's something we'll throw in on to say, okay, let's get it to this level so we can at least give them an indication of what it'll do. And then that's where things start to, drive into new opportunities and new systems and new requirements.
So what advice do you have to just aspiring entrepreneurs or just people that want to be involved in the blue tech industry?
It's a fascinating market, right? It's, where else can you get the opportunity to go hang out at the beach, get on a boat? And it's an important, it's hugely important when you look at the health of the oceans and what's there. At the end of the day, it's, how much risk do you want to take? And are you able to take in, going the startup route or going to, large companies? The benefits are, it's a stable paycheck, right? But the reward isn't there, obviously, from like a new start where you could get equity and things like that. So it's really a mix of, where you are in your life for, what you want to do. But there's certainly a lot of companies in the space, and you really can get in at any level that you want when from a company maturity standpoint.
What skills would you recommend someone pick up that's interested in? Is there a particular area that has like a lot of demand or a lot of opportunity for growth?
Um, you know, any engineering skill is highly valuable. Um, and I can't say enough about, I'm so glad that I went the engineering path and for my education. But from a engineering specialty standpoint, it's, I mean, if you go to the basic pay scales, it's hard to contend with software, right? Software, AI, ML, those areas are just in such high demand, really across the country. Um, and I'm I'm a hands-on hardware guy. I always have been. But it's depends where your passion is, where your skill is, and there's certainly demand signal, and even non-technical roles. Like right now, we're hiring heavily on the production side and the assembly side. There's a lot of opportunities in our finance and supply chain organizations. It's really the man the right now, I'm fortunate within Saab that we're a fast growing company in the US, right? We've added hundreds of staff this year alone. And I look at our group, we're going to be adding another 100 folks or so over the next year and a half. So it's a good time to be in the space.
Yeah, that's incredible. And it sounds like you mentioned loving being on the beach, on the boat, occasionally in the water. Is it sort of passe now to send humans deep underwater? I mean, we've seen, I think, recreationally a cooling because of like the Titan submersibles accident last year. But are there still situations where we want a human down there in that dangerous situation when there's a lot of incredible remotely controlled or unmanned systems that could just, or autonomous systems that could maybe do the job as well or better?
That's a great question, and I wish I were probably better equipped to answer it. But I mean, it's not too much different from space, right? You can put up some pretty incredible systems. You get a huge cost benefit when you take the man out of the system and the human out of the system, because now with instead of having to put the life support in there, the safeties in there, and all that, you can put more sensors, more power, more energy, more almost everything else. The challenge becomes how much capability is really there when we were made pretty well, right? For being able to assess, challenges and problems in the environment and do all the different things that, you can't always necessarily predict and build the right autonomy AI/ML for. I mean, certainly, I think as the next decade is going to be incredible for where the tools bring us in AI/ML in particular, and how these systems advance further. And to some extent, it's probably scary, but I look at there's justification to put people depending on what the need is. I'm not a fan of deep sea tourism and what happened with obviously the Titan submersible. I don't think there was a reason for that. Clearly not a reason to end 4 5 people's lives the way they did. But yeah, there are a need to put people underwater, right, and put people in space. But that need becomes less and less, I think, as the technology matures.
Yeah, people got biological general intelligence. So once AI catches up, maybe the math will change. But I know for space exploration, a lot of it is about the human experience and connection. And I'd probably argue there's still some place for tourism underwater just for kind of communicating, the experience and the importance of the ocean to people.
Well, like I said, I'm an avid scuba diver, and I think, you know, you look at and really, I've seen some of the numbers since COVID. The number of divers are growing exponentially, right? People are interested in the ocean, and that, have the certifications, do it safely, but when you start looking at, yeah, and I mean, there's a lot of good submersibles built in the world, right? They're exploring some deep areas. It's mostly science missions. It's not really for the tourism side. There's still some tourism activities happening, but they're focused mostly shallow, get people in the water. When you look at, historical shipwrecks like the Titanic, should people be going there? There's been a lot of debate there. There's been some collisions with it on prior dives, even from a scientific standpoint, that damage it, right? Uh, it's a concern.
Yeah, certainly.
For our audience members who are hearing you speak and the color and work of your career, and are like I want more. Are there particular resources, events, certain I don't know, ecosystems that would be sort of maybe good next steps that people who are getting interested in the space but are not experts like you yet, that they should look up and plug into?
Um, for naval systems, there's a lot of trade shows, obviously. It depends, the military side or the scientific oceanographic research. One of the best shows every year, in my opinion, is in London called Oceanology. It's actually every other year. That's coming up in the March timeframe. There's some conferences in the New England area. Blue Innovation Symposium's a great smaller event, networking heavily from the New England community, from across the board, right? Blue tech, sensors, vehicles. When you look at sort of the bulk of the market, and there's some hot spots, Southern Florida, California, that area, but a lot of this technology really developed initially out of MIT and Woods Hole. So the corridor in the Southeast New England area is most every one of my competitors are within 50 miles of where I'm sitting right now, right? There's a lot here.
Are there international hotspots also that you would recognize as like maybe near peer?
Um, I think I'd be fired if I didn't say Sweden.
Okay.
Yeah, no, I mean, Sweden has a tremendously strong capability for subsea. And I love where I've sort of been able to go in my career, but coming into Saab and starting out with a tremendous product portfolio, it made my life so much easier when we were trying to start a new sort of division. The UK has a lot around oil and gas and focus there. Um, Europe is definitely growing blue tech. Nova Scotia, up in Canada, Halifax, Dartmouth has right across the bay there from Halifax. There's the Cove Center for Ocean Ventures and Entrepreneurship. Canada's put a lot into an ocean supercluster in that area, and really seeding a lot of companies and technology incubation to really grow a significant capability there. We use a lot of partners in that space. We actually have an office up there. Um, yeah, no, there's a lot of interest, really across the board. I think people realize that it's an important technology area. There's a lot of blue tech incubators and technology accelerators along the Gulf Coast, along Florida, um, West Coast. Just a lot of capabilities.
Jeff, I really appreciate you helping us to get a sort of 360 view of the blue technologies, particularly the autonomous and undersea work. Forrest, would you like to close us off and ask Jeff to do our tradition?
So Jeff, once again, thank you for joining us on the show today. It's a tough tech today tradition that all our guests say, stay tough. So would you be interested in looking at the camera and encouraging our audience to stay tough?
I'm Jeff Smith. Stay tough.
Awesome. Great. We really appreciate it.
And that's a wrap. So, yeah, Jeff, thank you again. It's really cool.
Awesome. Thanks, guys.
Really fascinating stuff. Hey, it's J-Mill. Remember, check out our sponsor, The End Effector, at endeff.com. That's endeff.com.